Hey guys, welcome back. I'm back at the college again. This time I'm having a look at a Mitsubishi Triton 2010 model, common rail diesel, 2.5 litre. It has an issue with a check engine light on. So let's see if we can make this complex thing into a simple one. And notice the other lights go out, but that check engine light stays on. So this is called a hard code, or a code that will stay there and won't clear because it's an emissions fault. Quite a range of scan tools on the market, some cheap, some more expensive, and you get what you pay for, obviously. This particular one that I'm looking at the moment is called a Launch C-Reader V. Even with this cheaper brand of scan tool, it's come up with a code, a P0403. Exhaust gas recirculation control circuit malfunction. So because it's a control circuit, this refers to a circuit fault, not a performance fault. So if we scroll down, we have another one, a P2413, which is the exhaust gas recirculation system performance. So this is a performance fault. So they're all related to the EGR valve, which is of course an emissions fault. What I'll do now is I'll skip across to the G scan, so that'll give me more control. I can do activations, etc., but I'll show you that next. A scan tool will have two areas where you can get your diagnostic codes from. This area here, over in diagnosis, or in OBD2. This is the area that legally you must be allowed to get your codes from. This area is from the engine manufacturer, and he can decide what information he allows you to have. Very nice of him, of course. So we'll go into OBD2. We'll go to diagnostic trouble codes. Notice what it says here, pending codes. That means that it hasn't actually completed its drive cycle, and it's just going to confirm those fault codes when it completes its drive cycle. But notice what they're all related to: exhaust gas recirculation, EGR. So we can see that there's a real problem in that particular area, isn't there? Possibly one of the most underutilized tools or pieces of data that we can gain from our OBD2 section is called freeze frame. Now what freeze frame does is, as you can see, we've listed all our codes here. So these codes, as you can see, they're actually mirrored. It's just updating there. Both of them have gone from pending into confirmed. So they went from I'll let you know if they're going to be a fault into, yep, I've tested them and they're definitely a fault. So the beauty of this button down here, freeze frame, they will be different for different scan tools. Some are actually in the main menu of the OBD2 section. So just look for that word freeze frame. What freeze frame means, once it fires up there, is that at the time of the fault code coming on, this was all the data that was going into the ECU and out to the actuators. It's interesting because we noticed that the engine was hot. It was at 81 degrees. It was only idling. It was 974 RPM. He was doing it 8 kilometres an hour, so he's just cruising down the road slowly. The air intake temperature was okay, 18 grams per second. That may be a little bit high perhaps. Fuel rail pressure, all those pieces of information. The command to the EGR would have been 0%, which would have been quite normal for a low RPM. So it's interesting to find out this information. Look out for freeze frame. It's really excellent area to find data that will help you find the fault. What we'll do is we'll go up to current data, and that'll tell us what sort of information we've got. That check engine light has been on for 1,211 kilometres, so he's been driving around with it on for a while. What else have we got? Command EGR, 0%. So let's actually just start it up and see if we can get that EGR valve, see if that's going to read or not. want to do is carry out what's called an activations test. And what that does is allow me control of various actuators within the system, and hopefully I can put the EGR valve off and on, and that will tell me if the circuit is okay or if the circuit's faulty, and if I need to look further. So even before I get out of the driver's seat, I will be able to determine most likely if it's a wiring fault or if the EGR itself is faulty. We'll try actuator test, and hopefully we'll be able to switch the EGR off and on. I'm not sure if this will come with that option or not. Check engine light, glow relay. EGR valve, there we go. Right, so we can select EGR. We've got a few options that we can do, and then we'll go down to EGR, select 100% open. So because it's saying each section of the EGR valve is actually opening, that gives the indication that the circuit is okay. But next I'll look up those fault codes and find out if they can give me a clue as to where to look next. While I don't recommend diagnosis by internet, the internet can be very, very useful with data. It's hard here in Australia to find accurate data that you can access, but here on the net we can get a lot of information. One of the main things when I'm trying to find a fault and a result to a fault code is by going to the net and having a look at what's called conditions to set the particular code. As you can see here, I've put in one of our codes, which is a P0403. One of the advantages is that we can scroll through the information and it gives us potential symptoms, the causes, the possible solutions, and also related codes. Now, some of them you can go into and it will actually give you how it sets. This has some useful information in it too, because it actually tells you the test procedure to go through when you're looking for this fault. Here's another site that has some interesting information on it, because it talks about, of course, the EGR being defective, but not only that, if the information from other sensors doesn't go to the ECU, then that will not activate the EGR. For instance, if the MAP sensor is faulty, if the EGR pressure feedback sensor is faulty, then the ECU can't give the proper information to activate the EGR valve. The other code that we're looking at now is P2413. I've done the same sort of check, and it's interesting because it actually gives us the code set parameters, and that will let us know when the EGR valve or when that fault code will activate, the reasons behind its activation. Of course, it has some more common faults. It could be a clogged EGR valve. It's fairly common on these Tritons for that to happen, particularly the diesels. So I really need to do a systems check on the actual EGR, find out where it's located, and see if we can activate it, and also look for clogged passages in the EGR itself, and then hopefully that'll be able to sort out its problem. I've had a look through our Autotech encyclopedia, which is a bit of an old school one, but looking at the Navigator Pro didn't provide any information at all on this model, so I've gone back in time into our Autotech encyclopedia. If I had a look under the EGR system, as noted here, it gives us a control valve. It also shows us where to test our voltages at the ECM. It also gives us information on a position sensor, which is actually held within the EGR system itself, and of course there's the pin numbers there at the ECU. See what it says here. Note, I mean, this is most likely what the fault is anyway, but it's important to do the diagnostic process properly. Notice what it says here. It is common for the exhaust passages of this system to clog over time. Mitsubishi recommends cleaning carbon from the EGR valve, all passages and the intake manifold at regular intervals when the tappets are adjusted. So this is a common fault, not just with this vehicle or this model, but across the board, particularly with diesels. So the next step we go to is having a look at our pinouts on our voltage tables. So we go over to here on the second page, and it says A19 is the control valve motor, so it's actually a motor, and we're looking on pin A19. That will give us a variation of volts depending on the RPM at the time. And of course over here on A20, that is the negative side of it. It gives no information, but that's the negative side. If we go over to here, and get it straight, it has a position sensor in it, which is actually a potentiometer, and that varies according to whether it's idle or high RPM between 2 volts and 1.5 volts. And on our next page we have the sensor ground at all times, which should be 0 volts, and we have pin A80, which is our positive at all times, which is a 5 volt reference. Over here on our wiring diagram, the item number is 155, and that there is the actual EGR valve, that one there. And pin 80 is the one that has the 5 volt reference into this potentiometer, as you can see. And A72 is our ground at all times. So we should be able to check that circuit, and then we should be able to see the motor. Perhaps put a current clamp on here to see if the motor is actually working when the vehicle is revved between idle and say 3,500 RPM. The EGR valve is in quite a nice position. It's located on the passenger side of the vehicle near the rear of the engine. Easy access. We'll just zoom in a little bit there. You can see it's located between the inlet manifold, and it's got a pipe going down to the exhaust manifold, of course. I've managed to put a set of dressmaking pins, which is what I use all the time. These little fellas here. Where am I? There we go. Okay, so little pins there. I use them all the time to back probe the wires so that I don't actually damage the wires. So even though I don't have a wiring diagram as such, I don't have the colour codes, I should be able to nut out which one is which. I know there should be an earth there at all times. I know there should be 5 volts there, 5 volt reference when the ignition is turned on. Then there should be a variation, has a little position sensor in there, and of course the motor should have continuity through it. So that's what I'll check next. So I've got the negative lead of my multimeter on the negative side of the battery, and now I'm just going to check for to find that earth at all times. So we'll just go through my pins, and what have we got there? Alright, that's in kilo ohms, that's clearly not it. There's one over here, kilo ohms once again. One in the middle is reading, just a bit of a bad connection there. Okay, so there we go. It's 0.8 of an ohm. So we know that that one, this one here, is our earth at all times. So the next one I'm going to look for is go to volts, and I'll look for my 5 volt reference when the ignition's turned on. There we go. So we've got the earth at all times is this white one here. The red one, which is convenient, is our 5 volt reference at all times. So all that's left is the motor and also the output of the potentiometer. I guess one of the main problems is that without a throttle cable under the bonnet, it's very difficult to do any testing of any description at revs. So what I'm going to do right now is just check the motor and make sure it's got continuity through it. If it's got continuity, then we know that there's no open circuit in the actual motor itself. I've been able to figure out which of the wires are the motor one, and they will be the bottom two. I'll just give you the multimeter readings so that we can have a look at that. But the bottom two, keep in mind it's just a motor, so it'll be a coil of wire, and if I can get a good connection, we will read approximately 5 ohms, and that's quite okay. The other wire therefore is the signal wire. So at this point I feel quite comfortable to pull the EGR valve apart to to give it a good clean out. I'm sure it's just blocked with carbon. All the tests that I've done so far indicate that we've got a 5-volt reference, we've got an earth at all times, the motor is in good condition. The tests that we did with our actuations indicated that there was no fault, there was no open circuit in the wiring, so that's okay. And the potentiometer is a little bit difficult to check at this time, but I feel confident to go ahead and clean out the EGR valve. You can see the EGR valve is quite full of carbon all around the place. Even the piping that it goes into is quite badly carboned. If you get a light, it's not like it's totally blocked or anything. If you get a light through it, you can see the light. I've just got a light under it, and you can see the light coming through, so you know that it's not totally blocked, it's just carboned. The EGR valve, however, is it's not like it's stuck or anything. What I do notice is, though, there's quite a bit of wear in the bush, so whether it's actually sticking at times as well, that's possible. But I'll clean it up. As you can see, there's carbon all over the place, and I'll clean that up and just carry out some further activations on it. But if not, I reckon they're going to be up for another EGR valve itself. You know, when I pulled out the EGR valve, I thought it would be totally blocked and it would be obvious what the fault was. But I'm having second thoughts at the moment, so I'd like to diagnose just a little bit further. I figured, well, while the EGR valve is out, I might as well have a play with the actuations, and we'll just go into that. The actuations test is what I referred to before, and I can go in here and turn on the EGR valve 100%, 50% or 0. So as you can see over here, there's our little motor, and that should activate backwards and forwards. But note what happens when I hit start. We're not seeing the motor move, are we? So I thought to myself, perhaps it's a communication issue, maybe that's the problem. So I thought, well, I'll put the throttle valve, this fella here, through my actuations test and see what happens there. You notice that the throttle plate there is moving. Never stick your fingers in there, by the way. And that's going through the test, and then it returns. In fact, I can go through all the sections there, 90 degrees, we'll select it, we'll start it, that should go to 90 degrees, as we can see. We'll cancel that, and if we want to go to throttle, valve 0 degrees, which is totally shut of course, we can start that, and there it goes, look at that. So I know I'm communicating with the vehicle okay, but I'm not getting communication to my EGR valve, so this is the issue I need to trace further. Round 2. I'm back here at the college a week later. I've done a lot more research on the subject with regard to these fault codes. I've been in contact with the organisation, the Automotive Technician, TAT, and the assist line has been absolutely fantastic, and I've got a direction to go now, so I'll give you a bit of an idea of my thoughts on where to go next. It was suggested to me to apply power to the motor, the EGR motor, which I wanted to originally, but I was unsure about the voltage because I couldn't find the voltage anywhere. I've been told it should be 12 volts. My next step is to clear those fault codes, because apparently with this particular model what can happen is, unless the fault codes are cleared, the ECU will go into a protection mode, assuming that the EGR has a fault, and therefore it won't allow you to activate the EGR valve motor. So the second thing I'll do is clear those codes. At that point I will activate the motor through the activations, and hopefully it should work. If it brings a fault code back on, that's okay, because what it should be at that particular point is a carbon build-up within the inlet manifold system itself, the EGR and everywhere else. Now when I pulled the EGR apart, it didn't look too bad. I was surprised. But apparently the inlet manifold has a real issue with these common rail diesels. In particular, another thing that I've noticed, I'll show you shortly, is the turbo has a leak, an oil leak externally. Now what can happen there is, of course, air can be drawn in through those seals, and the oil, etc., comes into the inlet manifold, and then that continues to help build carbon up. So I'll do some more testing, but I really feel strongly that the main issue here is carbon build-up with the inlet manifold. The ECU is just trying to protect itself by bringing on the fault code and no longer allowing the EGR valve to work. I'm also going to suggest to the customer to get his turbo either serviced or replaced. It's done a lot of kilometres, so we'll find out the next step in that particular area. But I feel that the turbo is also a contributing factor to the carbon build-up and therefore the EGR problem. It's quite a long-winded process, but it's the best way to diagnose this particular fault. So let's get back into it. So I've got my motor connected up now, and between pin 4 and pin 6, positive and negative, 12 volts I'm running into it. So let's see what happens when I try to extend it. I might just hold it here in case it comes off its spindle. There we go. So it's extended okay, and it being a motor, I should be able to reverse it and it should pull back in, shouldn't it? So let's have a look and see what happens. And it pulls back in. So I know my motor is now okay. There's no issue with it whatsoever. One thing that I haven't checked at the moment is inside the EGR motor assembly is a potentiometer. So I need to check that. And we have 5 volts here, we have 0 volts here, and our output, our signal wire, is this one. So I've extended the wire a reasonable amount and we can see it's up to 3.89. So if I just manually push the motor back in, we should see a change in the potentiometer reading. And as we push it back in, we can see it going down. I know that the motor works, I know that the potentiometer works, so I know that that motor assembly is working fine. I've just rescanned it and noticed that there's a new code that's come up. That's a U1101 and it says CAN timeout not equipped. So let's go and have a look and see what that represents. I found the code on one of the sites on the net, U1101. Interesting, as we scroll down here, possible symptoms is the malfunction indicator lamp on, which is true, and function limitation. Notice this one here, it says component protection active. So that lines up with what we thought originally, is that the ECU is actually trying to protect itself from overcurrent because the EGR valve is sticky or worn out or bunged up with carbon, and therefore it would raise the current and therefore it would damage the ECU when it tries to activate the motor. So even though this is a new code, it still lines up with the diagnosis, the direction that we're heading. It's a few weeks now since I looked at this Triton last. The guy's been really busy and I haven't been able to get his vehicle in to have a look at it. I did originally clear the codes, the EGR codes. I didn't get a chance to have a look at live data at the time, so that's what I'm going to do now before I put in an intake cleaner spray, and hopefully that'll help sort out some of the issues. So for now, all I'm going to do is hook up the G-scan and have a look at some live data and make sure that the EGR is operational and the ECU is allowing it to operate. I've now got on live data. EGR valve appears to be working. Can't quite see. 70 something percent, I believe. Yep, 70 to 80% at idle. If I bring the RPM up, let's have a look. Let's bring it up to say 2000 RPM or close. Something like that, and we've got about 50 something, 60%. It's a little bit different from years ago where EGR never operated at idle, but these common rails seem to engage their EGR even at idle. So it's good to know that it's actually working. So our next step is to clean the intake system. So to inject the spray into the intake system, I've had to disconnect the map sensor, which is over here, the vacuum hose that goes into the inlet manifold, and I've put in a T-piece to put my spray in. Why didn't I just spray it under the bonnet, you ask? Well, the problem being is this has an electronic throttle body, therefore there's no cable to turn it off and on. I have to bring the revs up to about 2.5 to 3000 RPM while I'm spraying it in. I can't do that from inside, so I've extended my hose for my spray. I'll do it inside the cabin, and I can raise the idle up to my 3000 RPM that I need to do it efficiently. I'm using a product called Wins Diesel EGR4. It's well known for being a good product. We'll give it a shot. I've never used it before, but here's an opportunity to see if it works or not. So the goal, remember, is to get it up to about 3000 RPM, give it a few squirts, let it stabilise and continue on till the can is empty. So let's give it a shot. So I'm going to get it up to 3000 RPM and then squirt it 4 times and just let it stabilise. Been a bit of white smoke coming out the back, and this is quite normal to be expected considering that we're putting a high hydrocarbon through the engine to drag away that carbon. It'll clear up shortly, so no need to panic. That's all part of the process. So there's our EGR after the clean. We're looking at 67.1% at 650 RPM. We bring the revs up. Dropping down to 30, 40, 56. So we can see it's the ECU is pulsing the EGR solenoid, and that's opening the valve and shutting the valve accordingly. So far that's a fix, but the problem being obviously the intake system and the turbo having an oil leak, the exhaust having an exhaust leak. There's a few issues still with this beast. But for now, this is a fix, which is excellent news. I've just got back from a road test. I'm happy with the way the vehicle is running for now. I will recommend to the customer that he has a good maintenance schedule with regard to cleaning the intake system with spray. It is important, as you saw, to make sure that you have a good diagnostic path to try and repair the vehicle. We had a look at the fault codes. We found out what creates that fault code, what triggers the fault code, and what sort of system is involved. In this case, we had an EGR fault. It was a little bit tricky, I must admit, when we couldn't get it to activate, but that's just a protective system of the ECU itself. So guys, I hope you've enjoyed this video. I hope you've got some sort of benefit from it. I know I've learned a lot in this process. If you did enjoy this video, please give it a thumbs up. If you haven't already, make sure you subscribe to the channel and feel free to give your comments down below. So until next time, this is MiracleMAX. See you later, guys.